then you know it goes up to the right and down to the left. Okay, so the function goes, move that over, up and to the right. Which means f of x approaches infinity as x approaches infinity, and it goes down and to the left. Which means your f of x approaches negative infinity as x approaches negative infinity. Okay, so actually these two would be your answer. That's the end behavior. So that's why if you can remember just the x squared and x to the third and how those graphs look, it will save you a whole lot of headache trying to remember everything else. All right. So any questions on that one? All right, I'll leave that up for a second. Right. Okay, so let's say, for example, you want to determine the end behavior for the function, say f of x equals x minus 3 times x squared plus 5x minus 1. Okay, so we need to know the degree, we need to know whether n is odd or even. Okay, so I'll just rewrite that. Equals x minus 3 times x squared plus 5x minus 1. Okay, so here we know that's degree 1 because that's the same as x minus 3 to the first power. And I'll just, no need to write the degree. And we know this one, that lead exponent is 2, so we know this is degree 2. So we know this entire thing is degree 3. Which means our n is odd. Okay, so we know our n. Yes?
What about the degree of 5x?
Oh, that's just 1. Yep, 5x to the first power, because that first power would just be 1. So out of this entire 1, if you have a degree 2, degree of 1, and a degree of 0, you're going to pick the highest one. All right, that made sense? All right. All right. Any other questions on this point? All right. Okay. So now we can see that the number in front of here, I'll just rewrite it. F of x equals, I'm going to give it a little more room. Why do I keep on the right plus? X minus 3 times x squared plus 5x minus 1. Now, if you notice here, that's just, you can kind of put a positive 1 there. Okay, so that lets us know our lead coefficient is positive. So we know altogether that n is odd and our lead coefficient is greater than 0 or positive. Okay. Which again sounds like x to the third. And we'll do one that doesn't sound like x to the third in a second. So similar to x to the third, which we know x to the third looks like that. Okay. So if we know x to the third looks like that, it goes up and to the right, down to the left. Okay. So we know that f of x approaches infinity, well, when it's up and to the right. F of x approaches infinity as x gets bigger. And when it's down and to the left, f of x approaches negative infinity as x approaches negative infinity. Okay, so those two would be our end behavior. Any questions on this one? All right, I'll leave that up for a few seconds. All right. Okay, so let's say, for example, determine the end behavior for, say, f of x is equal to negative 5x times 2x plus 1 times x plus 9 times x minus 3. Okay, so if we go ahead and rewrite that, negative 5x times 2x plus 1 times x plus 9 times x minus 3, we can see here that this factor, that's just to the first power, that's to the first, that's to the first, and that's to the first power. Okay, so you have degree 1 here, plus degree 1 there, plus degree of 1 here, plus degree of 1 there. So this entire term is degree 4. Okay, which means n is even. Okay, so if you did all the distributing and FOIL method and factoring and all that, you'd end up with the highest exponent of 4. Okay, we can also see that for negative 5x, clean that up. You have 2x plus 1, x plus 9, and x minus 3. Your lead coefficient is negative. Okay, so you know that means a sub n is less than 0, or or negative. Okay. So that means we have an even degree, or n is even, and our a sub n is less than 0. Okay. That kind of sounds like negative x squared. Negative coefficient, even exponent. Okay, so we know negative x squared looks kind of like that. So we know the endpoints for this one are going to go down to the right, down to the left. Okay, so that means f of x approaches negative infinity as x approaches infinity. Remember, that's your down, that's your to the right. And you're going down and to the left. That means your f of x is going to approach, again, negative infinity as x gets smaller. Okay, so these two would be your end behaviors. Let's move that up a little bit. Okay. Any questions on this one? All right, so we'll do one more. Oh, no one's still writing. All right. Okay, so what if we wanted to determine the end behavior for f of x equals negative 3x, 4x cubed minus 1 times 7x squared plus 1 times x plus 1. Okay, and I'll leave that one, give you a few minutes to start on that one. Remember, the first thing you want to do is find the degree of each term. I mean, not each term, each factor. Excuse me. Alright, so let's start on this one. F of x equals negative 3x times 4x to the third minus 1 times 7x squared plus 1 times x plus 1. Okay. So we see here, this one, that's like saying x to the first, so that's just degree 1. And for this one, the lead exponent is the third power. So that one's degree 3. For this one, the lead exponent is to the second power. Excuse me. So that's degree 2. For this one, the lead exponent is to the first power, so that's just degree 1. Okay, so you add those together, you get degree 7. Which means n is odd. Okay, so now we can see our lead coefficient. I'll just rewrite that so it's not all jumbled up. Okay, our lead coefficient is negative. Okay, so if n is odd, and our lead coefficient is negative, excuse me. Okay, that kind of sounds like negative x to the third. Odd exponent, negative coefficient. And we know if x to the third kind of looks like that, then negative x to the third kind of looks like that. So it goes up and to the left, down and to the right. Okay, so remember, up and to the left, okay, that just says is our f of x keeps getting bigger as our x gets smaller. And our f of x gets smaller as it goes to the right. So down and to the right just means our f of x gets smaller, approaches negative infinity as x gets bigger. All right. So any questions on that one? All right, so again, if you can just remember how positive and negative x squared and positive and negative x to the third looks, it kind of helps you not have to remember all that other stuff. All right. Okay, we're going to do a quick review of intercepts. It's pretty straightforward, so we're not going to spend a whole lot of time on them. Okay, your x-intercepts are points that cross the x-axis. And your y-intercepts are points that cross the y-axis. Okay. Now, if you want to find the x-intercept, you make y equal 0. If you want to find the y-intercept, you make x equal 0. So So you just make the opposite equal 0. Uh-oh, x-intercepts. But in a lot of these cases, instead of y equals 0, it'll be f of x equals 0. Since y is equal to f of x. To find the y-intercept, you just make the x's equal 0. All right. So, for example, find the x and y-intercepts for f of x equals x minus 5, x minus 4, and 4x plus 4. Okay, so to find our x-intercept, we'll make f of x equal 0. Okay, so that means x minus 5 times x minus 4 times 4x plus 4 equals 0. I just kind of switch it around for my own little personal quirk. You can leave it the other way if you like. Okay, so now you just solve each individual one or set them all to 0. So x minus 5 equals 0. X minus 4 equals 0, and 4x plus 4 equals 0. Any one of those will make this true. Okay, so if we subtract 5 from both, add 5 to both sides, it means that x equals 5. If we add 4 to both sides, x equals 4. If we subtract 4, then divide by 4, we have x equals negative 1. Right? So your actual x-intercept aren't those values there. It's 5, 0, 4, 0, and negative 1, 0. Those are your actual x-intercepts. And now for your y-intercept, move that up some. You just make x equals 0. Okay, so f of x is equal to, instead of x minus 5, it's going to be 0 minus 5. Times 0, well, might as well say f of 0 to be completely accurate. 0 minus 4, 4 times 0 plus 4. Okay, which ends up giving you negative 5 times negative 4 times 4. Negative 5 times negative 4 is 20. 20 times 4 is 80. Okay, so your actual y-intercept is 0, 80. All right, so any questions on that one? Hopefully that seemed familiar. quick note. Sometimes when they say finding the x-intercept, it will sometimes be called finding the zeros of a polynomial. Okay, so finding the zeros just basically means the value where y is equal to 0, or f of x is equal to 0. Oops, sorry about that. So if you see them say find the zeros of the polynomial, they basically just mean find the x-intercept. All right, so let's say, for example, if they said find the zeros of the polynomial f of x equals x minus 2, 2x plus 1, x minus 5 times 3x plus 2, you'd find it the exact same way. You'd set f of x equal to 0, or y equals 0. So find the zeros. Remember, that's the same as find the x-intercept. And you do that by making f of x equal 0. All right, so that means that x minus 2 times 2x plus 1 times x minus 5 times 3x plus 2 is equal to 0.